Hello, everyone. Today in Flan, we have Rémi Eyraud, who's a professor at IUT Saint-Étienne, who's broadly been working at the intersection of machine learning and formal languages. And in particular, he's done some work on grammar induction with context-free grammars, and more recently on extracting weighted automata from RNNs, which is some work that I have been following in particular. And today he's going to be talking about something related to this, basically a new challenge that he's co-organizing on extracting automata from neural networks. And I think this is exciting and very on brand for this group. So excited to hear more about it.
Yeah, thank you. Well, it's a work in progress. That's the first thing I have to say. So there's a lot of open question, still there. So I'm happy to have a discussion. You stop me whenever you want, and discussing. And I have question for you. So feel free to intervene. And yes, it's exciting, but it's a lot of work, and we're not ready yet. So you see a lot of logo, but I think it's better to talk about, oh, it's not working. It's better to talk about with people, right? So basically we are 3 person working at first on that, and some other journalists. So there's Shiro Shibata, that she's at the Hosa University in Japan, Jeffrey Hines, which is at Stony Brook in the US of A, and there's this firm Uranova, which is in Marseille. They're doing machine learning, and they are very interested by everything that is about interpretability, understandability of neural nets. And so they're around. We actually have a project with them. That's why they were around when we started to discuss this idea of a competition. And they're helping us a lot by providing nice engineer in computer science, but also foundings and stuff like that. There's also some interns that worked during the summer, and one still working now. So Eyraud, Badr, and Marwan, they are in France, all of them, but they're not French. And so they work, and most of the code we are using are from them. We have a scientific committee. I'm pretty sure you know most of the names here. We had a lot of meetings during the summer to discuss the competition. Most of the time we didn't find a consensus. So that's why there's still open question, and I'm happy to have some feedback from you guys. Okay, so what's the competition about? Our idea is to provide already trained neural network, between 15 and 30 of them. They will be all trained on sequential categorical data, okay, sequence of symbols. For each of them, we're gonna ask the participant to provide a simpler model. And we'll say automata extraction. Yeah, it could be automata, but it could be anything else. We are happy with grammar. We are happy even with neural nets. Okay, if it's a small neural net, we're good with that. We hope that automata and grammar will do better than neural net. But yeah, we are planning to have no restriction on the type of model that people will be able to upload as a solution of as a smaller model to the one we provide. So there will be 2 tracks. The first one will be about formal language learning, okay, binary classification task. And the second one will be about regression. Think language modeling, neural network, or any density estimation. But we still don't know exactly if we're gonna go into any regression, like give me a real number that could be any real number. That's an open question that I will be happy to discuss with you. So 2 tracks, one more formal language, one more usual use of neural network. The type of neural network we're gonna consider, simple recurrent neural network, GRU, LSTM, with a large spectrum of number of layers, number of cells, the optimizer use, whether it's bidirectional or not. Well, you know, all the hyperparameters that we can have. So we're gonna try to have a lot of diversity on the type of recurrent neural network that are going to be provided for the competition. We're gonna have transformers because that's something that cannot be avoided right now, but not much. We aim at one per track. Okay, we're gonna fine tune. Actually, we try to learn from scratch transformers, and it failed. So we're gonna fine tune already trained big model. As far as I know, we only found some NLP one. So if you have transformers for something else than NLP, I'm happy to look at them and see what can be done with them. Yeah, basically that's what I want to say about the different type of neural nets. So some idea for track one. We have artificial data that's gonna be used. Okay, how are we gonna train our recurrent neural network, our transformers? Well, we're gonna use artificial data. We have some stuff about subregular classes. We have some data for context free. So there will be training data that are coming from that. We also have some biological data and some software engineering data for this binary classification task, for this formal language task. We looked also about NLP task, like sentiment analysis, where the idea is not to give a value, a real value, but like, is it positive or is it negative? Is this comment positive or negative? So in this case, it's a binary classification. If you have any data that you think can be used for the competition that is real world, small alphabet, and binary classification, I'm very happy to hear about it. Why not? Why small alphabet? Because this competition, maybe I should have said that. This competition is done in the context of the ICGI, the International Conference on Grammatical Inference. And we know that having big alphabet is usually difficult for the kind of algorithm people of this community is looking at. We will have, like for our previous competition, we will have one or two data sets with big alphabet. But this is easy to find. But small alphabet is harder to find. So if you have any idea, again, I'm very happy to hear it. For the second track, the regression, okay, we have Hugging Face, we have a lot of data that are available. We also have some artificial data. There will be some stuff about sentiment analysis. Actually, there's a huge choice. For this task, the problem is not to have data. The problem is which one to pick, knowing that we want, for instance, this question of, okay, we want to train neural net not only on language modeling tasks. We want to train the neural net on, I don't know, scoring between 0 and 10, a value between 0 and 10 could be a real number, or even negative values. I don't know. I mean, I have some data coming from senior, but it's senior, right? It's not categorical, symbolic input. So you always can discrete that and work from that. But if you know a data set that has that kind of features, I'm very happy to hear about it. So why? Maybe, I don't know why. I mean, machine are not that good. Why do we want to do that? Why do we want to work on this competition? Well, the first thing is that there's a lot of different distillation algorithm right now, extraction of finite state machine or whatever, which means that it's likely that there will be a lot of people interested by participating, which is actually something important when you do a competition. The first competition ICGI organized, there were 2 participants. So we really want to avoid that, and we think that this idea, this competition has the potential to bring a lot of different participants. When you organize that kind of competition, you always have 2 different things that happen. The first thing is that you push the state of the art. Participants, they're trying to push their algorithm to the limit of what it can be done on this data, okay? So usually you have new ideas coming from that. But there's also this question of providing a benchmark. It's something, the reason why I started to work on this competition 1 year and a half ago now, the first time I discussed with Jeff about this idea, it was because I read a paper comparing comparing to another paper. Actually, they were comparing with the work of Galway's, supposedly on the same architecture, supposedly on the same RNN, trained on the same task, and the number they were giving were not the same than in the original paper. And they're not. I don't think they were cheating or anything. They really follow what they were saying in the paper as the number of layers, the number of neurons per layers, the type of neurons, the type of gate. It was LSTM for this example. But again, there's so many hyperparameters that even if you follow everything that is in the paper, it's at the end you will have a different neural network. And then you use the same algorithm. Actually, they were using the code that was available on GitHub that Galway and her co-author gave on GitHub. And actually, they achieved for the same scoring function different values. When you have that in science, it's not good, right? You need something. You need the benchmark that everybody used to compare their results to what the other algorithms are able to do. So when you organize a competition, basically that's what you have at the end. You have this bunch of data. In this case, will be already trained neural network that you can use to compare yourself with from a algorithm. So well, that's the motivation of this competition. The hard part is the evaluation. For the quality of the approximation, how close the model extracted is to the original trained RNN or transformer, well, that's quite easy, right? If we have a test set and if we did a correct job at creating this test set, you can run the model, extracted model, the submitted model by the participant on this test set and look if you are in the case of binary classification, you just look at the agreement or accuracy, right? If you are in the case of the track 2, like the regression, if it's density estimation, you can use perplexity, Kullback Leiber, likelihood, spectral norm, whatever. Okay, there's a lot of ideas. It's not that clear what we can use if it's real regression. It's not density estimation. It's real regression. But I mean, there's a lot of idea also here. It's not difficult. The hard part of the word interpretability is still here. Actually, we worked for a while on finding a metric for interpretability, and unless one of you have submitted recently a paper with a metric for interpretability that I'm very happy to hear, yeah, that doesn't exist, right? So the idea is simplicity. So we're gonna look at different metrics for simplicity. The first one is the running time on some test set. Okay, we're gonna evaluate all the submission on the same server in the same condition, and we're gonna look at the running time. This will give us an idea of how quick, which is linked with how simple, right? Is the uploaded model. The second idea that is complementary is look at the model size when in memory at runtime. Okay, when everything is uploaded, the model is here ready to be used on the test set. What's the memory footprint? So this will give us also an idea about the simplicity of the model. We know it's not perfect. There's been a lot of discussion in the scientific committee about that. There's a lot of reason to not use one of the, I mean, one against each of these idea. But there's nothing better than that. I mean, if we force people to extract automata, for instance, well, then yeah, there's a way to define simplicity for automata. Compute the canonical one and look at the number of states or the number of transitions. I mean, there's a lot of possibility, but we don't want we decided early on this work that we don't want to force people to have a particular model to extract. I mean, there's some work about extracting context-free grammars. We want people who did this algorithm to participate, because I mean, you can do a lot of things with context-free grammars. So basically, it's a hard question for us to allow any model, but I think we have a solution. But it's forbid us to use AIC, BIC, all this thing that is based on the number of parameters within the model, because it means that we will have to have a different script to compute the metric for each type of submission, which is not doable. So unless you have other idea, right now the idea is to use these two metrics for simplicity, and not to have a leaderboard where basically you can look at who is winning in terms of quality of the approximation, who is winning in terms of running time, who is winning in terms of memory footprint. And then we will see how we decide who is the winner of the competition. If we really need a winner, we can have several winners, or I don't know. That's still an open question. But if you have another idea for evaluating the simplicity of model, and please don't say Kolmogorov complexity, yeah, I'm happy with that. I'm happy with any idea. And again, I'm presenting you a work in progress, and any feedback is very welcome.
I have a question about that.
Sure.
So is there some type of human evaluation that you could do? Like basically, if you give the model to humans and try to have them explain something about its prediction?
No. I mean, it was on the table at the moment. The last time I participated to an interpretability competition like that, basically the interpretability was decided by human. We asked participants to do a 10-minute presentation and explain how their model were interpretable and everything like that. Thing is, people who loves automata, who knows automata, you show them an automata even with hundreds of states, and they found it interpretable. But people who like deep stuff, deep learning stuff, you show them the behavior, some neural nets, they run some stuff on it, and for them, they understand how it works. So it is impossible to use. I mean, it's not impossible. It's not a solution to use human to determine the interpretability. Or you need to have people who know nothing about anything, right? Like you take your first year student and you ask them to evaluate which is the most interpretable model. But yeah, it's that's why I thought I erased the interpretability stuff. I was just wanted to talk about simplicity. Marco raised his hand.
Yeah, I was curious, like, I mean, I don't know, maybe you guys have thought about these already, but like, for example, the running time one, you know, if you said that you aren't excluding neural models or whatever, but some models maybe implemented on like GPU versus CPU and things like this, like, are these considerations that are coming into it? And then the second one for the model size, a lot of my work has been on quantization, which like makes things, you know, up to 30 times smaller, but no more interpretable in any way. And so I'm curious, like what is there going to be some laundry list of like restrictions on what sort of stuff you can do with models and whatever?
So there will be a restriction. For instance, we're gonna evaluate the models only on CPU. So if your model rely heavily on GPU, too bad for you. Okay. In terms of the second part of the question, yeah, that's why I wanted to erase this interpretability, and I forgot to do it. I mean, if it's very small, I'm happy with that. One of the big problem of the neural nets is that, well, basically you cannot run them on a phone, or it's running bad on the phone. So if you're able to come up with a very small model that is not interpretable at all because you quantize it and it's it's still a black box, but a small one that actually is able to run smoothly on a device like a cell phone, well, I'm happy with that. It's really like the title is about extraction of simple model, and we forget about extraction of interpretable model, which is bad. I mean, that's not what we wanted to do at the beginning, right? But it's, yeah, I mean, I cannot sell interpretability. And simplicity is already great. There's already a lot of good idea, a good thing to have a simple model, even if it's still black boxes. I do hope that at the end we will have something interpretable. The winner will be will come up with something interpretable. You have other questions? Good. I'm continuing there. Okay, so we are currently learning something like 100 and actually a bit more of neural nets, and we're gonna select 10 to 15 of them for each track. So it's gonna give us 20 to 30 neural nets. We're gonna look at the diversity. I already said that, right? The different type of architectures, number of layers, type of gates and everything. We also want to select them based on difficulty. We wrote two baselines, simple baseline, right? The baseline that you look at the hidden state and you do some clustering on the hidden state, and simple but usually quite good baselines. So we're gonna provide the code of this baseline. I actually can show you. It's a bit drafty, but it's close to be a final version. So we're gonna use this baseline to have some easy to extract neural nets and some hard to extract neural net. Okay. What else? We use Python 3.8. All models are learned using PyTorch, and we provide them in two forms. The first one, we're gonna provide a GitHub with the model object, the train RNN, with some description dictionary that will give you anything you need to open the black box. Okay, and also we're gonna give the needed function for encoding, decoding symbols. Okay, so that's going to be the first thing to do. If you don't like PyTorch, if you don't use PyTorch, or if you have an algorithm that doesn't need to open the black box, we're gonna provide MLflow models. So MLflow, there's other competitors to MLflow. We tried this one, it worked well. So basically, it's a picker, right? It's a picker. It's a binary stuff. You get it, and then you can give some input and have the output of the model on any input you give to it. So that's how we're gonna provide the data. We're gonna provide also, of course, everything about the versioning and the models that are used by the neural net, but it's basic stuff, right? We didn't went for fashion stuff. It's basic PyTorch. As already said, we're gonna provide notebooks with the baseline so that participants will be able to see an algorithm used on the model of the competition, and then they will just have to plug their own algorithm inside this notebook if they want to test their own algorithm very easily. The big question that I think this one is decided now, unless everyone around today disagree and there's a riot online today, we're not going to provide the data used for training, because basically if I'm giving you that, you are able to train a model from this data and not do the distillation, right? The extraction procedure that we are aiming at. So we're gonna give some data. I'm gonna give the validation set, which basically is usually 10% of the training data. I know that's a limitation for a lot of algorithms. For the track about regression, in which most of the model will be language modeling, it's not a problem because you can still generate the data using the model, right? For the track about binary classification, basically you can generate randomly some data set and then pass them inside your neural nets and have information about whether or not it's in the language. So there's a lot of different ways for you to have more data than the validation set, but I'm not gonna give you the training set. I don't want any cheating on that element. And close to the end, right? What we're gonna ask the participant to upload is just their model in the MLflow format. Okay, so yeah, given the metrics for simplicity I talk about, participant can I mean, it's a good idea for them to work on trying to have their model in the most compact format possible, right? To think about how to implement their model so that it's taking smaller possible memory footprint, for instance. But if we want to allow anyone to upload any type of model, MLflow is a good idea, because we're just gonna have to upload the model and then gonna pass some tests inside to see how close this model is to the original one, and then while doing that, keep trace of the memory footprint and keep trace of the time. So and that's very easy. I mean, you just have to install MLflow, and then it's like a picker. You just have one line of command and you store your model, and you can upload it on the website. So I think this part is the way to work with the competition. And I have a last slide. So that's the timeline. Still no call for participation. There's there will be soon. There's a front-end website till last week. I think the last slide has the link. It's on my own website right now, but it's gonna move to somewhere else soon. The idea is to have the competition website for real running beginning of January, with 1 or 2 neural nets, 1 per track, so that people can start to play and write down their framework and anything. The competition will start beginning of February and end of March. 1.5 months, 2 months of competition usually is what it takes, right? We know that most people will really compete between the March 15 and March 31, right? So basically, it's I think that this timeline is quite a fix. With the ICGI shares, we decide that people who participate and wants to have a paper within the proceedings of ICGI, they have to submit a paper by the end of May, so that there will be a review, like a short review, because we're gonna have short papers, like 2 pages to explain what you've done, and that's all we're gonna ask. So small review to be sure that what we publish is not nothing. It's really worth it, but still it's gonna be a quick review. And we're gonna have half a day on the competition at ICGI. So it's gonna be on July 10th. I think ICGI is July 10th to July 13th this year. It's in Morocco, in Rabat. So there will be half a day dedicated to the competition there. I think it's gonna be the first day. There will be tutorial and the competition the first day. And I didn't add, oh yeah. Some open question, yeah. Track 2, only density and simulation, I already discussed about that. We'll have a paper this year where basically he said stuff like overfitting is good. So do we do that? Do we overfit our RNN? Some of them, is it one hyperparameter the more that we have to add, like have some of them that are overfit? Data, again, if you have any data that you think can be useful for the competition, I'm happy to have them. I'm not saying we're gonna use it, right? The idea is to learn 100 neural nets and then decide which one we're gonna use. So it's not because you send me some data that we're gonna use these data, but still, it's I'm happy to hear about data set that could be useful. Of course, my main question to you guys is who's willing to participate? Because I don't want to organize that for two guys, right? I need participant, and I know that around here there's a lot of people interested by that kind of idea, and so I'm happy to have some positive feedback. But yeah, I'm considering that. Yeah, I'm gonna ask one student to look what can be done. That's yeah, basically that's all I have to say. There's a website. It's done. The website is done, but it's it's not the final URL of the website. And I have nothing more to say.
Awesome. Thank you. Maybe we can thank Remy, and then go to questions after. So,
Thank you.
so I guess for questions, we usually stop recording and then do it offline so people are more likely to ask.